Hey, good evening, guys. Um, Welcome back to my channel. Like I mentioned yesterday, today we're gonna do the one last example from stacking, and later on move on to example from Q as well. So without further ado, let's dive into it. I'm quickly gonna share my screen. Yeah, hope it's working now. So this is the question for stacking. We're trying to make the string great. So what does it mean by that? As you can see from the example, when you're going through this array, and if you see an element that uh, is same as the one before or after, but it's in the uppercase or vice versa. So for this example, we would have to delete this E to make it just small cases VEETCODE. So for the adjacent characters, if it's in the different case, then we have to remove it. So um, that's the main problem that we have to solve. Uh, so how are we going to approach this? And we also have to return the string after making it good. Basically, like in a stacking, we can directly apply the idea behind stacking, right? Because stacking operates behind the lethal principle, last in, first out. So, given a stack of strings, um, we're gonna go through it, and if the character that we're traversing through is um, the opposite case of the one that is already inside the stack, then we just pop it, right? Because we just have to remove the adjacent character that would make the string bad. And then move on and so forth. We don't have to care about the order as well. So it's pretty easy. I'll try to implement it. So just like any other stacking questions, you start with initializing a stack, and then um, for character in this in in S, what are we doing? So um, if first of all, we have to check if the stack is empty. So that will be no, if the stack is not empty. How do I index here? I guess it's around here, right? So if uh, if stack and what else? So we're checking if it's uppercase, right? The last element that comes into the stack. So that would be stack reverse index dot uh, Python has its own defined um, function for this, which is swap case. It checks the opposite of the case is character, right? If it's character, then we have to remove the last element, which is stack dot. I'll just put this as char stack dot pop. Now, if it's one that satisfies the function for making the string great, and then we just continue, right? So it will be else stack dot append character. Now we return the original stack, which is, how do we do that? We just join them together. So let's fix this index. Yeah, hopefully this is right. Oh, indentation for character. Let me a stack. I think I did it correctly, no? Stack dot append. Okay. Dot dot join stack. Huh? What's the problem? What do you think the problem is, guys? It should be really simple. Unindent does not match any outer indentation level. Huh? It does match it. Be like this. Yeah. No, this should be with outside the for loop. Oh, wait. Yeah, so the indentation problem was from the beginning where I initialized the stack and it was a bit off. So that's why when I was trying to indent it here, it didn't automatically go to the correct indentation level. That's why. But glad that I solved it. As you can see, it just returns the string great. Right. Let's move on to the next question. Q. Um, this one about the premium, so we can have a look at it. Given a stream of integers and a window size, calculate the moving average of all integers in the sliding window. So the principle behind Q is quite opposite of that of stacking, right? So while stacking is last in, first out, Q is first in, first out. So what that means is as the data comes in, the data goes out, dequeues from the other side. And that other side is where the data first started coming in. So that's why the first data goes out first, and then so on and so forth, and the last element goes out last. Right. So how is this useful for this kind of question? So as you can see, what we're required to do is um, as the numbers come in, we have to, there could be only um, three integers that we can calculate uh, the uh, uh, the average of, right? So in this case, for example, where they specified the size as 3, what would happen is, let me just bring my paint up. Let's say there's 2, 3, 7, 9, and so on and so forth. First, these three numbers come in to the queue, and then as we move on, we have to calculate the average of this last three elements, right? Because they specify the size as 3. So how do we disregard this 2? Well, you're correct because we are using the queue. This by principle, first in, first out, it leaves the queue. And then we can automatically calculate the moving average of these three last numbers. And then if a new number comes in, let's say for example 10, then we again move this um, this average scale to these last three elements and these three DQs, NQs and DQs, right? So that's like the logic behind this question, directly applying the Q. So how are we gonna try to solve this question? So basically, um, the class is given moving average, uh, and inside size, we have to initialize size and Q here, right? So self dot size equals size, and what else? The self dot Q equals the square brackets. Now, this is where we have to specify the operation and how we are going to calculate the moving average. How are we going to do that? So we're going to specify what a size and Q is here as well because we have to use it. So size and Q equals self dot size and self dot Q. Now, we have to simulate the appending of the value, right? The value in this next function. So that will be size, Q append val. Now we're simulating the coming in NQ operation for the Q. And now we have to calculate the actual sum of the moving window. So that will be window sum equals to um, the sum of the moving average, which is Q, and we're coming from the last element. So size, right? In the simple indexing. Simple indexing. Now we return window sum divide by the number of the elements. That would be length of mm, uh, wait. Yeah, so we have to divide it by what's lesser, either a length of a queue or the size. So either one that finishes first, we divide it by it. So that would be min length queue and size. So let's see if this works. Yeah, so as you can see, it correctly returns the case result. Yeah, so that was it for today. It's a pretty simple question, although the queue, um, I heard that in Java they have like this own method to visualize queue, but in Python as well, it's pretty simple, so I don't think that would be a big issue. I think for me myself, I'll do maybe I'll move on to another part, the next part of stacking and queue. The course that I'm following is from NeetCode and LeetCode, DSA course. So I recommend to check that out if you're also in the same situation like me, trying to improve the algorithmic skills. But anyways, that was it for today. And thank you guys all for listening.